All right, so for today's class, we're going to be looking at solving absolute value equations and also solving linear equations, and then using that to figure out what the solution is where they intersect. And if there's not an intersection, what does that mean? And explain a little bit more about that. So we want to look at, we're looking at linear and absolute value functions. Remember yesterday we talked about quadratic, and we know quadratic functions are generally in a U shape, a parabola, or it could be an upside down U. We know linear, right? Linear functions are generally straight lines. Now today we're talking about absolute value functions. Absolute value functions, the graphs. We want to look at what does it look like when we graph absolute value functions. And simple, they look like a V. Here it is, a V. That's not there, or upside down V, something. That's what they look like. All right, so we know quadratic, we know linear, and now we're just going over some absolute value function. A couple of things we're going to look at when we're talking about plotting and graphing linear and absolute value functions. So say for instance, you have an absolute value function, and let me do like an estimated graph thing on here. Say for instance, this is my graph, right? And I have the absolute value function on there. And then I'm going to get a linear function. And say, for instance, my linear function goes like that. So then I could look at it and say my point of intersection is right there. And if it goes across the line again at some point, that's also another point of intersection. So then that would be my solution to that problem. All right, if I have another one, just another rough draft, and say my absolute value function was here, and then I ended up having a graph, linear graph. So then it shows me that my point of intersection is right there. All right, so what we're gonna do, we're gonna pull up Desmos. So we're gonna look at two questions. The first one has equation y equals 2x minus 3, and that is our linear function. I'm gonna zoom out so we can see the whole thing. That is our linear function. Now let's put in our absolute value. So y is equal to the absolute value of x. You find that absolute value to the two lines, that line, that button above the enter button on your computer screen. If you press shift and then that button, it gives you the absolute value. So if you look at it, we realize that the absolute value, which is like the bluish purple, all right, and then the linear line, which is that green line, it shows us the point of intersection. So the solution for this problem would be, what is this, 3? 3. So I'm going to put in the point 3, 3. There it is, and label it. That right there is my point of intersection, and that's my point of where they intersect. That's my solution. I forgot to tell you, if both the graphs, they don't intersect, then it means no solution. Okay. We also want to look at what if the right side of my line, like right here, all this line intersects with exactly what I'm doing. So that whole thing right there gives me several solutions. So it's many solutions for that side. Okay, so it could just go across one way, could not touch it at all, or it could, the linear line could be the exact line for that side. So then it kind of changes. We just got to be observant with what we're trying to solve. Let me pull back up our Desmos. And there's the question we were doing. So we have the linear equation y equals 2x minus 3, which is that green line. And then we have the absolute value function, which is y equals absolute value of x. And that gives us that that v right there, and then where both lines functions intersect, that's the solution. Let's look at one more question. So we have y equals absolute value of 3 plus 3, and then this one is 2x minus 2. Let's take out this point because the point of intersection for this one is going to be 5. And then whatever this one is, 5, 6, 7, 8, 9, 6, 7, 8, 8. So it's going to be 5, 8. So my point of intersection for this is 5, 8. And that's where both those functions intersect. This is just a brief overview. I want to show you how the graphs get interrelate when we plot them. And then also, what does it mean when we're trying to find a solution of two graphs? And the point that we get, like the label, let me label it right here. So it up pops up on the graph. That point right there, what does that mean? And again, it's telling us that's where both those graphs intersect. Because if I take 5 and I put it in one of my equations, so let's take 5 and put it in my equation up here. 5 times 2 is 10, and then 10 minus 2 is 8. So my y value is 8. And I could take that same value 5 and put it in my other equation. So the absolute value of 5, right, is 5. And then 5 plus 3 is 8. So they both equal to 8 whenever I put it in, which is why that point refers to the solution of both those equations.